Hey, today we're going to talk about a special linear equation that's called direct variation. A direct variation is an equation that you can write in the form y equals kx, and you compare that to slope-intercept form, which is y equals mx plus b, and you can see that it's the same equation, only there's no b. Right? K is what's called the constant of variation, right? And that constant is considered to be the slope of the line. The y-intercept is 0 since there's no constant b. Right? That means that the y-intercept is 0. And what that means then about the line, if you were to actually graph it, if you graph the line, this particular line would go through the origin. So all direct variation equations will pass directly through the origin. Now on the next page I'm going to show you a simple example of a common everyday situation that can be modeled using direct variation. Now here's the situation. Joe makes $10 per hour. We have a table here where the x column is the number of hours and the y column is the amount of money that is earned. And we just put a couple of values in, start with $0 or 0 hours, and if Joe worked 0 hours, he earned $0. 1 hour, if you worked 1 hour, he'd get $10. If I triple the number of hours from 1 to 3, what would then happen is correspondingly the amount of money that Joe would earn would also triple, and he would earn 30. We then take that amount and double it from 3 to 6. The amount of money he earns would also double from 30 to 60. If we then take that amount and make it smaller, say divide it by 3, take 6 would become 2 hours work, and then the amount of money would also be divided by 3 and we get 20. And so you can write an equation, and here in green is the equation, y is equal to 10x, where the 10 is the constant of variation, and it's also considered the slope. And when you have a situation like this, what happens is as the x value is increased by a certain factor, the y, corresponding y, is also going to be increased by that certain factor, whether it's getting larger or possibly getting smaller. On this next page, we're going to run through a few examples. And it's important to see that it says first sentence here, the variables x and y vary directly. So what we're going to do is we're going to use the given values to write an equation that relates x and y. So basically in each situation you have one ordered pair from a direct variation relationship. And so for each one of these, what we'll have is we'll take our direct variation equation, y is equal to kx, and we will substitute in. Right? We know that y is 10. We know that x is 5. And so basically we just solve this simple equation here, divide both sides by 5, and you're going to get that k is equal to 2. Right? We will then take this value right here, plug it right back into there, and we can write our equation, y is equal to 2x. And that's it. And basically what we're doing here is we're finding the slope. Right? And we could do this other ways. Right? But in this particular case, all we're doing is plugging into this equation and solving it for k, which then allows us to write the equation. If you look at the second one, we do the same thing. Y equals kx. And we plug in, y is 20, x is 8. Divide both sides by x, and we're going to get that k. Divide each side by 8, rather. We're going to get that k is 2.5. Again. Take that value right there, plug it right back up into here, and we can write our answer. Y is equal to 2.5x. And we could check that. Okay, we plug in y is 20 and x is 8, so you take 2.5 times 8. 2.5 times 8 is 20, so 20 is equal to 20. Okay, the next example, okay, here's our direct variation equation. Okay, we plug in y is 4. X is 12, and in this one we're going to divide by 12 on each side. Okay, and I put this one in here because on this one, a common mistake is for people to not get the 1/3, but rather do 12 divided by 4 and try and say that the answer is 3. In this case, you're doing 4 divided by 12, and so k is 1/3, and you get k is equal, or y is equal to 1/3 x. Okay, the last one then, I made one of the variables negative, and it's also going to be a fraction. I have 20 is equal to k times negative 24. You divide by negative 24 on each side, and you're going to get that k is negative 5/6. Again, you'll take this value and you just put it right back in there for k, and you write your answer. Y is equal to negative 5/6 x. Now on the next page, what we're going to do is we're going to start off the same way. So the examples, when you look at them, okay, they both start off again with x and y varies directly. I should have written that also in example 2. But they tell you in the first one that x is 4 when y is 20. Okay, and that's just like what we did on the previous page. Okay, but we're going to take that and we're going to write an equation, and then we'll use the equation to find out what y is when x is 7. So we start off with, again, y is equal to kx. Plug in everything that we have. Y is 20. X is 4. Divide each side by 4. And you get that k is 5. And that gives us this equation. Y equals 5x. Right? And then what we'll do is we'll use the equation y equals 5x. To find the value of y when x is negative 7. And so what we do here is take the equation, y equals 5x. We substitute negative 7 in right here for x, and you find out that y is negative 55. So it's very similar at the beginning to what we did, but then after you find this equation, you actually use it to figure out what y is. Now, the second one is basically the same thing, except in this one, we're going to be finding the value of x in the end. So you start off the same way with your y equals kx, substitute in the things that you know. Y is 4. X is negative 10. Divide everything by negative 10, and you get that k is negative 2/5. That gives you this equation, negative 2/5 x. And we use we use y as 12, so we plug in 12. Put 12 in for y. And solve the equation. And you'll solve the equation by dividing by negative 2/5 on both sides, right? Or if you wanted to, you could multiply by negative 5/2. Either way, you're going to get that x is equal to negative 30. And that's the correct answer. That's it.